We looked at a way to rationalize denominators in an earlier video where the denominator was just a monomial, meaning it had only one term. So something like 10 over square root 5, we said instead of just stopping at 2 times 5, we can further break 5 into root 5 over root 5, root 5 times root 5, and then we realize that one of the root 5's cancels with the denominator, and the answer is simply 2 root 5. Now, in this video, we will talk about denominators that are binomials. So you have two terms in the denominator. Now, before we get into that, I want to remind you of the difference of squares formula. A square minus b square is a minus b and a plus b. Now this formula forms the basis of this video. What it says is if you have difference of squares, you can always factor into a minus b and a plus b. So if you see something like a square minus 9, you quickly realize that this is a minus 3 times a plus 3. Now, if you have something like 4x square minus 25, then you know 4x square is the square root of, or 4x square is the square of 2x, and 25 is the square of 5. So your factors are going to be 2x minus 5 and 2x plus 5. Or in other words, you want to think, where is 4x square coming from? It's coming from squaring 2x, and 25 comes from squaring the 5. Now, one thing that I want you to realize is you can think of a and b also as squares. So notice, a could be thought of as square root of a quantity square, and b is square root of b quantity square. In fact, that's what we have been doing here. We thought of 5 as the square of root 5. So if you think it that way, then you can factor this a minus b as square root of a minus square root b, and then square root a plus square root b. Now, how is this going to be helpful? Well, it will help us in rationalizing denominators where it's a binomial. So say I'm given this problem, x square minus 7 over x plus square root 7. So notice, this is a perfect square, but if I think of 7 also as a perfect square, not of an integer, well, x square comes from x, but 7 comes from squaring root 7. So I can break it down as x minus root 7 and x plus root 7. And look, one of the factors matches with the denominator. So you can cancel that common factor, and here is your answer, x minus square root 7. Now let's look at one other example. Say you have m minus n over square root of m plus square root of n. So again, we can think of m and n as squares. So m comes from squaring root m, and n comes from squaring root n. So a is root m and b is root n basically. So this is going to be root m minus root n times root m plus root n, and the denominator is root m plus root n, which matches with one of the factors. So you can cancel the common factor, and you are left with square root of m minus square root n.